Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome Kevin Stewart. Kevin is an experienced educator and maintenance and reliability professional with 39 years of practical work experience in a variety of roles for ALCOA Primary Metals Group and ARMS Reliability. At ALCOA, Kevin initially worked as a plant engineer and moved on to become the corporate reliability manager and reliability consultant for the primary metals division. After leaving ALCOA, he became the lead RCA trainer for ARMS Reliability. In 2016, Kevin founded KPS Reliability, where he provides training in Apollo RCA methodology and consulting to organizations that are looking to establish a root cause analysis program. Kevin has a degree in mechanical engineering from the University of Washington in Seattle, and he's a licensed professional engineer. He also holds a CMRP certificate, that's Certified Maintenance and Reliability Professional. Kevin, welcome, and thanks so much for joining us today.
Well, thank you for having me, Tim.
So, Kevin, I think most of our listeners by now, I hope, have heard of root cause analysis, and some of them may actually have some experience with RCA as well. Can you tell us about some of the more common mistakes that people make when they try to apply RCA?
Yeah. There's, I'm going to say there's about 4 or 5. Let's start out with 4 things that I think most people end up having difficulty with. I think number 1 is you probably have remembered the saying, "If all you have is a hammer, then everything looks like a nail."
Oh yeah.
What that means is that if you have root cause analysis, we can solve the world's problems with that. So,
that's not true. I'm sorry.
Well, we'd like to think that, but unfortunately, what I see is that people when they get this tool, they think it can solve the world, so they use it where it shouldn't be used. I've seen people try to use it to solve all sorts of things. And I go, well, shouldn't you be using something like a failure modes and effects analysis on that? And they look at you kind of funny. And so that is a big issue, to use it where it's not correct. And the problem with that is if you do, then you won't get the best results. And then, of course, they blame RCA type of thing. So I always say when it's used appropriately, it's the right tool. It does a good job. But if, as anything else, if you try to use an orange to pound in a nail, it doesn't work so well. So that's one. Sometimes they'll use what they call SME, as you mentioned, and you're as a subject matter expert for a facilitator to do the problem. What that means is that you go in to do an analysis, and you'll say, "Hey, we're going to work on this particular problem," and the gentleman that they put in, the person. I'm an old guy, so those terminologies aren't that shouldn't be right. So the person that they use to do that may be from the particular area where the problem is. And unfortunately, it's not that they can't do a good job. It's much more difficult because they have preconceived notions, understandings. Sure. They may not ask the right questions and all those things. So another big problem is they use subject matter experts as facilitators, and they shouldn't. Those people should just be in the analysis and provide information as necessary. Another big one is they stop too soon. We see this all the time, especially in new people. Is you go down there and say, "Well, what happened?" "Well, let's see. We had a shutdown of the unit. Why?" "Well, because this gearbox broke." "Okay, fine. So what did you do?" He said, "Well, we fixed it." "Well, how?" We replaced the gearbox." "Well, yeah. Why did the gearbox break?" "Why do I care? I restored flow. I'm up and running. What do I care?" I went, "No, you do care, because if you find out that it's because you put the wrong darn lubricant in there, then guess what? That you're just going to have another failure." So you see it all the time where they don't go far enough to get to the true cause. They restore flow, and that's a big problem. So stopping too soon, you never get to what. Another one is what we call, a lot of people call systemic issues, which means, lack of PM. And you can say, "Well, we didn't have a PM in there." Great. But you need to ask one more time, "Why didn't you?" "Well, we have no program to install PMs on new equipment." So all of those things are related to the same thing. They just don't go far enough to truly get to a point where they can address an issue to prevent it and or many other possible issues coming back, especially in the systemic side.
Kevin, isn't this why they always tell us to ask the 5 whys?
Yes. Yes, to some degree. However, let's not confuse that with not going too far, because even if you ask 5 whys, which, by the way, is I don't want to say a misnomenclature, but if you talk to the folks that are into 5 whys, they'll tell you that, yeah, I know it's 5, but guess what? If you can do it in 3, that's okay. By the way, if you can do it in 7, that's okay. And if you can do it in 10, that's okay.
Right.
And the problem with not going too far is with the 5 whys is it's a great program, but it's not for everything. So if you use it in the wrong spot, again, that can be an issue. So you have to make sure you go far enough to get to a true answer. And the 5 whys, you could still ask 5 whys 10 times, 15 times. But the problem with that is if you start getting that far, you may not ask the right questions, because 5 whys is not designed to be repeatable, which means that you get 15 different people. You could potentially get 15 different answers. So,
wow.
So you got to be careful with 5 whys. It's not it's a good program. It's used for low consequence operators engagement, all those kind of issues. It's fantastic. But for more sophisticated problems and or things that have large consequence, you got to use something different, and then you still are stuck with this, say, not going far enough.
When you were describing the problem earlier, I've heard some people refer to it as the fuse effect, that you're replacing a component that failed, but really that component was just working as a fuse. It was the thing that failed, but it wasn't the cause.
Correct. That would make a lot of sense. And in reality, you normally associate fuses with electrical equipment. A lot of people would do that, but the concept is exactly the same. If you put too much power in there and you bust the gearbox, it becomes the fuse, and it broke theoretically to prevent something else from breaking. And if you fix that, a lot of times people put in a stronger gearbox, and the problem is that, as you know, if you put a bigger fuse in, you just burn up your house, because it's not good, I think. So the idea is to figure out what the problem is.
Exactly. Kevin, when we talked earlier, you mentioned the work of Winston Ledet at DuPont, who I guess had some kind of disappointing results when preventative maintenance was initially implemented. Could you comment? Could you elaborate a little more on those findings? Does root cause analysis play a role here?
Yes, I think it does. He didn't have so much. He did talk about PM at DuPont. It all bore out of the Nolan and Heap study from United. A lot of reliability folks would recognize that, where they did some work with airplanes, and they said they found out if they did more PMs, they had less crashes. That was good. So they said, great, PM equals good. So they did more. Well, crashes went up. So they found out that was a big issue with PMs. The Winston Ledet folks looked at the overall strategy that they put together, and it was Ledet and Paish were the two people, and they were at DuPont. They did a study, and they started looking at it, and they said, well, what's going on here? What if we do more of this, less of that? So they looked, and they said, if we do scheduling only, they got a 1% increase in their output from the basis of reactive maintenance. If they did planning only, they got a 1% increase. Surprisingly enough, if they did PM and PDM only, they got a 3% decrease. I believe for the same reason that you talk about that, more PM is not necessarily the best.
Got it.
And then what happened was they said, well, what's going on here? What if we put all three together? They got a whopping 5% increase in their output from the systems. But then they came in and said, what if we add defect elimination, or another term would be the root cause analysis? What happens? Well, they found out they got a 20% increase.
Wow.
And and we are just working with clients right now where I think a little bit of an understanding might be appropriate, because people are going, what do you mean? Well, we just did some RCAs, we call them 5 whys, on some issues. And the three top issues they pointed out, they said, here's the issues that are killing us on this particular piece of equipment. I said, what are they? We looked at them. I said, well, let's talk about them. And all three of them would never have been fixed by adjusting your PM program or including this or doing something like that. They all needed a redesign or a process change in order for you to eliminate. And those three there were the highest they cause the highest total downtime in that particular equipment. So the concept of defect elimination works in integration with all of the other things. You have to do the planning, scheduling, PM, and all that, but you have to couple it with this defect elimination in some form or another, because otherwise you're never going to achieve the value. So because some of the things don't have anything to do with that program. You don't want to be just efficient at doing bad maintenance.
Yeah, that makes a lot of sense. Also, it seems like a lot of times preventative maintenance is we're just following the schedule instead of really looking at failure modes.
Right. Absolutely. And I think I mentioned before, maybe I didn't, but you can make the case that says that so fine, I go in and I replace a bearing every year, and I never have unplanned maintenance. Nobody ever knows anything. Everything's going fine. We're happy as a clam. And this has actually happened to me. When we go and do a little looking at it, you find out that you should be replacing that bearing every 8 years. So here I am being very good at scheduled and planned maintenance, but my costs aren't going down the way they should because I'm not doing the defect elimination. That says I'm not running it the way it should be.
That makes a lot of sense. Kevin, I've had a chance to lead some root cause analysis investigations of my own, and I find that, unfortunately, in a lot of cases, this leads to some finger pointing or some blaming. People start looking for someone to blame for the failure instead of trying to look for other reasons. Do you have any advice for quality and reliability engineers who want to focus on solving the problem instead of looking for somebody to blame?
I think so. I can tell you, I agree with you. I mean, it's pervasive. You can keep the. I can't remember where I saw it. I think it was a movie with Sean Connery, but it was. I remember it. It said, "Fix the problem and not the blame." And so, if you keep that phrase in your mind, it will help you. And some of the other things that go along with that, there is some data out there that says small, like 0.6% of the U.S. population don't know the rules. And it's even less in business. And what that means is that people do not get up in the morning and say, you know what, I'm going to screw up today. I'm going to do something wrong. I don't want to be safe. That's just not what happens. So
I agree.
If it's that small, do not look for that to start with. I'm not saying that it doesn't exist. I'm just saying that don't start out looking for it. Look, instead of the terminology that we use is error of action. Error of intent is I got up this morning. I said, I'm going to take a sledgehammer and beat my car up. Error of intent. Error of action says they get up in the morning. They're going to try to do the best they can, but they have a lack of skills, knowledge, understanding, or lack of a memory lapse or something like that. There's a cause for that. So you would not blame somebody for having a bad day. I use the phrase, I've heard that before, let those among you who have not screwed up, be the first ones to cast a stone. So
something about living in glass houses. Yeah.
Right. So when you're doing this, you have to keep that phrase and think about the fact that may happen, but don't look for it. If you continue to look for the causes, which are not, the error of intent,
right,
then you'll get to a point where you can accomplish your goals. I've had a couple of clients say that the other problem that you're going to have is that if you do that, your program goes to heck in a handbasket. And I had a client come up one time and says, yeah, we had a situation where, we had a tank and it was full of pure water. And if you look in the tank, you were supposed to see it was empty, but the water was so clear you couldn't actually see the level. So some guy looks in, thought it was empty, wasn't, screwed up the batch. They then did a RCA and they identified this issue and they said, yeah, I did it. And then they fired the guy. Well, guess what? Nobody in the facility ever wanted to help them again with an RCA because who among you would say, yeah, would you mind helping me fire you? No, nobody's going to do that. So you got to be very careful about that. And your program will die on the vine. And once in a while, statistically, you may find somebody, but that's an exception.
I really like the way you put it. I don't think anybody wakes up in the morning wanting to do a bad job. At least that's my starting point. And I also like what you said about checking for things like understanding. Did you understand? Did we communicate effectively? Do you have the proper training to do what's necessary? Those are, I think, smarter places to start when you're trying to address a problem like this?
Yeah, human factors studies. I'm not an expert in that field, but I know enough to be extremely dangerous, I suppose. But human factors would say that if you've I'm going to mess up some of the numbers, so help me with that. But if you do a task all the time, you probably aren't going to. The risk of making a mistake it gets low. And if you do it once in a while, the risk goes up, and you could do some things about that. But if you're in what's called, I think one of the trainings that I got called it the knowledge mode. If you're in the knowledge mode, meaning you walk up to something and you go, I never seen this before. I wonder what I should do. The odds are that something's going to happen. And there's all sorts of stories about that where they do the best they can, but they push the wrong button and all heck breaks loose. And so you just have to be aware of that if you know where everybody is and what they did, they tried to do the right thing. But why would I chastise the guy because he tried to do what it wasn't? He didn't have the proper training, but the place is on fire, and that's what we got to do.
Kevin, it occurs to me that maybe sometimes the problem is the culture or the just the kind of the way the organization works. I mean, we read all the time about quality problems at major corporations. Just look at Volkswagen and the emissions test results. What kind of culture? What kind of mechanisms are there for rewarding the proper performance versus punishing the wrong performance?
That's an interesting question and a comment, and then we see it all the time in industry, I believe, and maybe some of the listeners will identify with that. Is the scenario is you go out there and a piece of equipment breaks. So what happens is in the old days, and maybe even sometimes now, if you're in a reactive fire, some guy swings in. You've probably seen the picture. Swings in. He's got his Tarzan leotard on, and swings in and drops in. And he pushes a few buttons. He does this. He grabs parts from his locker and he fixes the thing, and everything's great. And what happens? Well, what happens is the plant manager and everybody comes down, pats him on the back, says, "Great job. We appreciate it. You saved us all sorts of money and all that." Right. Whereas, interestingly enough, I always used to look at that and I'd see it in our plants and I'd go, that's kind of interesting, because you should be saying, "I appreciate the work, but you know what? I really want to know why we had to do that, because that is not the right thing to be doing."
Yep. We reward the firefighting instead of rewarding fire prevention.
Right. So we drive that behavior, and it's not hard to do the other way. But the culture, if you have the culture of driving that Tarzan thing, then you shouldn't expect to get anything different. That's what everybody likes. And because of that, it's driven everybody to enjoy that. They get their satisfaction out of that. That's a problem when you move into high reliable systems, because people then go, I don't get that. Nobody ever comes and says, "Good job for finding out what the failure mode was on that," and and preventing it from happening for the next 20 years. They never say that. As a matter of fact, I used to tell the reliability engineers that reported me for a while, I used to say that the problem is going to be one of these days, the plant manager is going to come in and say, "I'm letting all you go because the plant's running just fine. I don't need you."
That's right.
So you go, well, that's a reward, isn't it?
It is actually a paradox of working in quality, that if you do your job well, then you can work yourself out of a job. Yeah.
Somebody came by one time when I was doing some work, and it was a department head, and I did a double take, and I came up and says, "Are you aware of what I'm doing?" He said, "No." And I said, "Well, let me explain to you." And what I was doing was the last time they did that job, it took them a week, and we were going to get ready to do it in 3 shifts because we had done all this pre-work and reliability work and stuff. And I said, "I just want you to know," I said, you would never know about this if I didn't tell you. So I learned from that you must, if you want to call it, advertise, because they just don't know.
Good point. Hey, Kevin, I'm going to shift gears on you a little bit here. One of the other things that we talked earlier about was reliability program strategy development. Can you explain to our listeners what reliability program strategy is, and maybe can you give an example also?
Yeah, the Ascendo site is a great one for reliability programs, strategy, etc. There's a lot of good work, and some of the folks on there have done some super work when it gets to literally the getting down into the nitty gritty about that. I'm kind of talking at a higher level in the sense of, if I don't know where I'm going, I may not end up there, or may end up a different spot. So the strategy kind of thing that I think is important is just to say, what are we going to do? When are we going to do it? What order should we do it in? And as an example, we went out to an area and they were having all sorts of problems. So we put together some ideas and we did a bunch of things. We fixed a lot of problems. The area got really better and it worked really well. But we didn't write down what we were going to do. And I remember thinking to myself when we went to the next area, I said, geez, whatever we did there worked. And so we came back and said, what did we do? So we wrote down the things we did in the order we did them in, and then started talking about, well, shouldn't we move this around a little bit because of these issues? We had things like if we didn't do problem defect elimination before we did planning and scheduling, everybody got frustrated because they're having failures all the time. So we developed a 10-step plan and said, fine, do them in these order. Put a cross-functional group in, establish measurement systems, do the basic PMs to some degree, then initiate some RCAs right off the bat. Then we said, fine, now that you got all that done, now I got to make sure my CMMS is up and running. Then start talking about PDM, incorporating that into the whole system. And then we're going to follow up with TPM. And each one of these things there was a reason for doing it that reason. When I tried to do TPM at the very beginning of this 10-step program, everybody's looking at me like crazy. They were arguing. They were, no, it won't work. Mechanics were screaming because they're going to take their jobs away. And it was just like, oh my God. So when we finally got down to steps, had done all the other issues up to that point, I found it interesting because the operations folks and the maintenance folks started coming to me and says, we ought to revisit this TPM thing because there's a lot of good things they could do. So it told you that there was an order and a proper time to do these in order to get them done effectively. The last one was not last one, but next to last, establish RCA as a way of thinking. You do the defect elimination, but you still have to put in place a program that says, okay, now that we got all that done, we're going to have fewer of these issues, but we still have to have a process that allows us to continue to do those things. So the kind of strategy I'm talking about is that scenario that says, when we applied this, we looked at that and said, I think I can take this in. If I got an area that's going bad, I think I can apply this strategy and get to where I want to go a lot faster without having to wonder, make mistakes, missteps, try to put things in the right place, the wrong place at the wrong time type of thing. So that's what I'm talking about when I mention strategy. I think that's the appropriate way, and everybody should have something like that, whether it's your own development or take advantage of somebody who's already done that, can help you get one quickly.
So the benefits of having a strategy as opposed to just solving one problem at a time, it sounds like you can move through the process a lot more quickly. Sounds like it's a lot more effective also.
I would agree. Even though one of my mantras is improving reliability by solving one problem at a time. There's two different things going on there, because if you're doing one problem at a time and just go around that methodology, that's going to slow you up. And I'm working with a client now that we're trying to do that, so you can do some things. But the way I perceive that one problem at a time is when you do work on a problem, you have to finish it to the point where it's done. Many people start going off on a tangent and try to do 100 problems. And I always tell everybody, I said, no. Right. We're staying focused on 1 to 3 problems, and we're going to get those dealt with before we add something to that. So
it's the whole point of doing a Pareto analysis, right?
Yeah. I'm sorry, I missed the first part. Did you say no sense in doing one?
No, I'm saying that is the whole point of doing a Pareto analysis.
Correct.
We want to prioritize our work, right?
We do want to prioritize our work, but at the very beginning, and I'm a big fan of that, you need to do that, and you need to know where that is. Sometimes you want to find the specific problem. Sometimes you want to know the Pareto to find what area to work on, so more of a category. So either way it works. I've also done it where in the very beginning, the Pareto analysis, you can make all sorts of discussions around that. That might be a good way to start, but I've had people say, "Oh, you got to do a Pareto analysis," and if I got stuff falling down around my ankles, I'm going, "No, Right now, I just got to fix stuff. So I can fix a ton of problems, small problems, in a very short period of time. Where somebody else is going to say, "Oh yeah, I took a month and Paretoed it out," and I'm going, "Geez, I've just solved 20 problems in the month." So now when I solve some problems, then I can come back and start saying I get a breathing room, I can do the Pareto, and that's the right thing to do to make sure I know where to go and all those kind of issues. So there's kind of two options, two ways to look at that.
But it seems like your primary message is you need to have a methodology that we say we're committed to continuous improvement, and that includes continuous improvement in how we approach reliability problems.
Yes. I would agree 100% on that. That's exactly what it is. You jump in there without some kind of concept, and you never know where you're going to end up on.
Kevin, this has been great. Thanks so much for joining us today.
I appreciate it. Appreciate the opportunity. Thank you very much.
So that was Kevin Stewart, president of KPS Reliability LLC. For more information, please go to kpsreliability.com or join the conversation at his blog on the same location. This is Tim Rogers. Thanks very much for joining us.